Hi, Mike Matchett with Small World Big Data, and I am pleased today to be sitting down with Charles Fan, the CEO and co-founder of MemVerge, and we're talking about memory, big memory, and some very cool things you can now do with memory using MemVerge that used to be only do with storage before. This is really mind-bending stuff in some ways for a storage analyst like me who's been around for a long time looking at SANs and distributed storage and aggregated storage and hyperconverged storage and disaggregated storage, and now we're doing some of the same things in memory, and it's just so cool. Charles, welcome, Charles. Uh, you are just tell us a little bit about your background. You were involved with VMware, and you did some cool stuff there
Yeah,
first.
yeah. All right. Hello, everyone, and thank you for having me here, Mike. So we started this company, MemVerge, about 5 years ago, and
Yeah.
before MemVerge, I worked at the VMware for 7 years, and I was leading the storage business unit, and my team created the product that you might be familiar with, Virtual SAN or vSAN, that basically is software-defined storage for virtualized environments.
I mean, creating a
Um,
whole industry there, software-defined
yes,
storage, right?
yes.
So, how did you get interested in memory, and what brought us to here, looking at
Yeah,
memory
yeah.
as the next frontier?
I think vSAN was an exciting product, and that really, changed the storage industry in some ways. And we want to keep pushing the envelope, especially as there are more and more data coming to this world, more and more data-centric applications. You need to process data faster and faster. And this is pushing the limit what the storage system can do. And so our motto is, what's next in storage is memory. We think only memory has the right latency and performance that can answer to the performance demand for modern applications. So we are basically trying to do some of the similar things people have done to storage over the last 40 years and apply similar concept to memory so that the whole application can be accelerated, especially when it comes to data.
All right, so a couple of things have been going on, right? We have Flash, which has made storage faster. We have persistent memory, storage class memory, which is a little bit slower than memory, but super fast and is like storage, and then it doesn't go away with a power surge. Then we have super fast networks and RDMA. We have lots of things going on with the way things get managed as resources in the computer. Uh, this opens up a whole new world of thinking, right? We no longer know where the line between memory and storage is going to be at the end of the day. But what are some of the things you're bringing up? Because it's in storage we operate at a certain threshold of time and distance. Memory is right there, and it's
Right.
very very short cycles on things. So what can we do that we used to do in storage and now we can do in memory?
Yeah. So there are a couple interesting concepts that we came to the realization. One is one of the important bottleneck for modern applications is storage I/O, and this we all know.
Yeah.
And when you look at what is storage I/O, it is the data being moved from memory to storage when it doesn't fit in memory or when you need to persist for long term. You move it from one place, memory, to another storage. And when you need it, you move it back. And this back and forth is storage I/O, is the input and output of the storage bits. And this is what slows things down. And now, if we imagine a new architecture where the memory itself can be expanded, where it become more scalable, it became even can go across the single node. Therefore, it provides enough capacity. And now imagine if the memory itself can become persistent, possibly, and can have interesting data services that before only available in storage, but now available in memory, so that we don't no longer need to move data to the other basket. So this is not reducing the speed or increasing the speed of I/O. This is eliminating I/O. So
Okay.
the thesis of big memory is I/O elimination, is how many of the I/Os in the application today that we can remove entirely by converging two basket, memory and storage, into one basket, big memory. And therefore, our company name is MemVerge. It is about converging into this one.
Okay. Okay, that's clever, right? I get it. Uh, what are some of the things that we're doing? I mean, in storage, I can tier things. I can tier between
Right.
different level storage. I can snapshot stuff. I can do some data protection tricks. Are
Yeah.
we bringing all that into memory at those speeds?
Yes and yes.
Oh my
and,
gosh.
and
Okay.
So yes, and much faster speed, the memory speed. So the what's leading the way, which you alluded to earlier, are some of the hardware innovations that are taking place. We are the software guys, so we take no credit on all the interesting hardware that's being created. So there are new storage class memory, persistent memory. So Intel shipped the product for Optane persistent memory. That's
Yep.
really interesting, a game changer there. And now there's a CXL new memory interconnect that's being introduced by Intel, AMD, and a whole bunch of other people. And you see the product from Samsung, Micron, and SK Hynix, and the Intel product will be moving to CXL as well. So you're going to have this whole new ecosystem of new memory hardware that are being created. So now you are dealing with the heterogeneity in terms of memory devices that are out there, and what the customer will need, unless they want to rewrite all their apps. If they don't want to rewrite all their apps, they need a layer of software that somehow virtualizes all these different kind of memory and creating some auto tiering capabilities between them, so that to the application they just appear as a single pool of memory without worrying about what data to place where. The software layer takes care of it, and that software layer is a software layer that we are creating. So we are creating this memory virtualization layer that can auto tier between the different tiers of memory, and then we're adding additional interesting data services to providing infra services to the application.
All right. So, I mean, we used to have virtual memory, right? Where on a computer where I would page, I'd have a virtual memory bigger than my physical memory, and I could page off to disk. Lots of problems and issues with that, but I got a virtually larger memory set. Now we're
Yeah,
talking about doing that across what you said, heterogeneous memory devices,
right.
and Optane. Let's call that out,
Yeah.
persistent. So now if I can move memory or use that memory on a persistent device, but yet still have it moved up when I'm using it in my DRAM, for example, I sort of get the best of both worlds now.
Yes, yes, you do. And I think virtual memory is actually a relevant concept to what we do. And it was the best we can achieve when you have a layer like SSD or hard drives,
Uh-huh.
which are operating at microseconds latency. The fastest SSD maybe 10 microseconds, typically at around 100 microsecond latency. And so the best mechanism is a paging mechanism, where the memory that you need to use, you to move to real DRAM. The ones you don't use, you move back here. There is certain overhead when you're doing this paging. So the performance of virtual memory is often not as good as if you use real memory. Now, with the hardware innovations that have taken place, the new persistent memory and CXL memory, they are operating at sub microsecond latency, usually at hundreds of nanoseconds. And at this latency, this allows memory type of access, which is your byte addressable load store operation. So this means you don't have to do the paging before you access the memory. So even though you have different tiers, you could
Okay.
directly access each of the tiers directly. There's still room for us to intelligently promote and demote pages from between different tiers, but the access doesn't have to go through the paging mechanism, which makes it higher performance at memories.
All right. So you have profiles in intelligent tiering that is also doing tiering within the memory levels layers, right?
Yes,
And one of the cool things I thought I saw was actually then you can do memory snapshots. I mean, just quickly, what
yes,
is a memory snapshot, and
yeah.
are applications okay with that?
Yeah, that's really the thing that we are most proud of, is a first data service we implement on top of this virtualization that allow us to capture the running state of a application
Mhm.
entirely into a encapsulation. And now this encapsulation can be restored at any time from anywhere. So you can move it to other instances, you can move it to storage systems, or you can keep it on the persistent memory or DRAM on the same server. And you can roll back to that instance to that snapshot at any time. You can move it to another instance and restart it there. Or you can, if you lose this server, you can restore this application back from that snapshot as well. So on top of this snapshot, you can enable better HA, better mobility, and better shorter time to results for long-running applications. And this would apply on the cloud as well as on-prem.
There are a
Very
lot of
powerful.
there's so many implications there, Charles. We could talk about this for hours because we're talking about how it affects you know, basically motioning applications around hybrid environments, cloud to cloud. We're
Yeah,
talking about how I build clusters, supercomputers, how I run big simulations with scratch
yeah,
storage dumps, how I speed up, you know, genomics research, right? The ability to snapshot memory and do it like that and restore like that to a running state is just tremendous.
yeah,
And
yeah,
and so you're not plugging in another card, right? You said you were software.
yeah. It's all done through software magic here.
Uh,
And certainly, I know we have limited time. If you need to find out more, come to our website, www.memverge.com, or just email me, info@memverge.com, and we'll tell you all about it.
All right. Awesome, Charles. I wish we could talk for hours because there's so much here. We'll definitely have to have you back. Maybe even do a couple little bit of walkthroughs and some use cases. With that, guys, check it out because this is game-changing architecture stuff. You're definitely going to see more of how to leverage these new memory types, these new architectures, how to get more out of your cloud. If you've got big apps, check out MemVerge. Thanks, Charles.
Thank
Uh,
you.
All right. Take care.